This is an activity to help you add polynomials. We're going to use algebra tiles to represent 2x squared minus 3x plus 5. And to that quantity, we're going to add the quantity x squared plus 6x minus 4. So the first thing that we're going to do is I want to just make an illustration of the first quantity. Here's your 2x squared. Here's your negative 3x's. And then here's your positive 5's. Okay, everybody with me so far? Okay, to that then we're going to add the second quantity, which is 1x squared. I have 6 positive x's, and then I have 4 negatives. Now, what do you know about the algebra tiles? Well, you know about the positive and negatives, because that's what we used it for earlier. Okay, they cancel each other out. In other words, if you have a pair, it's like positive and negatives attract, and remember, they zap out. They zap out. So the next step is to combine your like terms. So we're going to put all of our x's together, and are they all positives? So I end up with 3x squareds. Okay, now I look at all my x terms. I can have 3 pairs that zap out. I cross those out. I'm done with them. Don't need them again. They're gone. And I'm left with just 3 x's. And then over here, how many pairs vanish? 4. So I'm left with 1. So then the following is what you have as your final answer. 3x squared plus 3x plus 1. Then here's an example of subtracting polynomials. Gets a little more confusing. First, we're going to model the first one, 4x plus 5. Okay, so I have 4 x's and I have 5 positives. Then it says we're going to subtract or take away. You must remove there could be, yes, you could have an x squared. Then to subtract negative 3x plus 1, you must remove 3 red or negative x tiles. Well, do I have 3 negatives in here? Up here? No. So remember when we had our algebra tiles, if I had to put any in, I had to put a pair in. So this is what you're adding in right here. 1, 2, 3. Because I have to put them in as pairs. Because they zap out as pairs and they come in as pairs. Okay? So then now I want to take those away. Okay, and what do you have left? 7 x's. Okay, let me just review that part again. I have 4x and I want to subtract a negative 3 x's. But I didn't have negative 3 x's in there. Okay, 1, 2, 3, 4, 5, 6. I'm sorry. There would be 6 because, no, there should be 7. There should be a 7th. Okay, there should be a 7th. Don't worry about showing the tiles, because eventually I want you just to be able to do it in your head. But this will kind of help you when we get to the point. The negative or the minus, the subtraction is where we have a hard time. Okay, and we also then, I need to take away what? A positive 1. So I end up with 4. So yeah, I think this is a mistake there in the illustration. There should be 7 x's plus 4. All right, let's take a move away from the tiles then, and we'll look at, oh, they're doing it now with the added in inverse. And this is what I want you to eventually get away from doing with the tiles. Anytime I have a subtraction, like I've taught you before when you distribute, think of this as a negative 1. And I have to distribute negative 1 across the parentheses. So really I have 4x plus 5. And then I have a negative 1 times a negative 3x, which gives you plus 3x minus 1. Okay, and then I'm ready just to combine your like terms, and you're good to go. Any questions? I think so. I think so. All right, now, if one of you asks about can you write it going up and down versus going across, you can pick your method. I will have to say that before I saw this series, I was partial to the horizontal method. We're going to take the quantity 2x squared plus 5x minus 7 and add to it 3 minus 4x squared plus 6x. You don't have to start out by putting it in standard form. If that's something that really becomes a problem for you, then I may make that suggestion, that you rewrite both of them and put them in standard form. Just makes it a little easier to make sure you have everything in line. The horizontal method is first find the highest term. So I find 2x squared. To that, I'm going to add, but what is in front of this 4x to the second? A negative. So what's 2x squareds minus 4x squareds? Right, and that's where you end up, right here. A negative 2x to the second. Remember, your terms have to be alike. Not like we were doing with multiplication. We don't want to get those confused. The next one is I'm going to look at my single x term. I have 5x's here plus 6x's, which give you 11x's. And then I have negative 7 plus 3, which gives you a negative 4. And I like to solve it so that you do your highest term first, so when you're done, you are in standard form. We do like for you to, it's kind of required, just a requirement in algebra, that you state it in highest to lowest terms. Okay, now if you have more than one variable to a power, then you usually go with whatever the x is. Okay, if there is a choice, the powers of x. Okay, Tanner, here's your vertical method. If I have 2x squared plus 5x minus 7, then I'm going to add negative 4x squared, and I just line them up. But I've got to make sure that my terms are alike. Now, if I don't have an x term, then what do I put here? If I didn't have a 6x in my problem, I wouldn't put anything. You could leave it blank, or you could just fill it with a 0. And then you just combine them this way, kind of like you did with a system. Yes, they have to be like terms before you do this. They do have to be like, because I'm just adding them. I'm not multiplying them together. I'm just adding them or combining them. Put 0x. That's a good point. So you can see that there are no x terms there. Good point, Chase. We will. We'll do several. We'll do a couple together. Okay, then here's another addition one. They just show you again the horizontal method versus the vertical method. Let's do something. Let's try this one. I'm going to pull this down so that you can't see it. And let's try it. You pick which method you want to use, but we're going to find the sum of these two polynomials. You can just use it on a piece of scrap paper, it's fine. Okay, we do our highest term first, a 3y and a 2y to the third gives you a 3y to the third. Then we do our next term, which would be just a 4y, and there's a plus in front of it, 4y to the second. And then we have our y terms, a 3y and a minus 4y, which ends up with a negative y. If you put a 1y in front of it, that is okay. And our last one is the whole numbers, and you get a plus 3. Negative 5. Did we just do this? When you subtract, they call this, when you distribute that negative, it's additive inverse. Okay, and that's the method that I like to use. If I have a minus outside of a quantity, that means you kind of have to distribute or change the sign of every term inside. So I have a negative, it ends up to be a negative 3x squared minus 2x plus 6. Do you understand how we got all those? Thumbs up if you're good. Okay, looks like about everybody. Let's then move on with the subtraction problem. 3 minus 2x plus 2x squared minus 4x minus 5 plus 3x squared. Now try not to skip too many of the steps. I like to go ahead and change this to add. Change this to negative 4x plus 5 minus 3x squared. If you're comfortable once you've written the problem down doing that, that's great. If not, what I do is when I rewrite it out of the book, if it's there, I just rewrite it and change it right then. So then I'm good to go to combine my highest term, which would be x to the second. I have a 2x to the second, and what else? a negative 3x to the second, so I end up with a negative x to the second. Good. Okay, now my next term would be just the plain x's. I have a negative 2x and negative 4x, which gives you what? Good, negative 6x. And it looks like just whole numbers left. So I have a 3 and a 5, which gives you plus 8. Now, if you'd rather do the vertical method, just remember that you have to add its opposite and you change all the signs. Kind of like we did when we solved a system by the elimination method. You know, you might multiply everything by a negative and you had to go through and change the sign. So if you want to do it that way, there's not a problem with that. Any questions? Okay, I want you to try one subtraction problem on your own. Let's do 2a. 4x to the third minus 3x squared plus 6x minus 4 minus the quantity negative 2x to the third plus x squared minus 2. Okay, let's go through this one. I'm just going to change it. I'm going to add, so this would be a positive 2x to the third power minus x squared plus 2. Then I'm going to combine my like terms. The highest power is x to the third, 4x to the third, and a 2x to the third gives me a 6x to the third. Then I do my x to the second powers. Negative 3x to the second minus an x to the second gives you negative 4x to the second. Next term is my plain x, 6x. And do I have anything else to go with it? Nope, so it's just a plain old 6x. And then my last are my whole numbers, a negative 4 and a positive 2 give you what? Negative 2. All right, and that's your final answer. Okay, so let's try this one. Do I need to change any of the symbols? No, so actually I could just remove my parentheses. They're gone. Combine anything that is an x squared term. Well, what's 2x squared minus 2x squared? Nothing, right, so I have a 0. Now I go to my x terms. A minus 4x and a minus 5x gives you negative 9x. Thumbs up if you agree with that and had that. Good. Then I have my whole numbers. 4 and 4 gives you 8 plus 8. All right, now let's look at the one subtraction. 2x to the second minus 4x plus 4 is the same thing. But this time we're going to subtract a negative 2x squared minus 5x plus 4. How many of you are using the horizontal method? Yes, we're going across, horizontal. Okay, then I'll continue with this. We can rewrite this as I'm adding and I'm changing the sign. This will be a positive 2x, a positive 5, and a negative 4. So combine your like terms. A 2x squared plus a 2x squared gives you 4x squared. A negative 4x and a 5x gives you, don't forget to put plus an x. And if you have a 1x in front of it, that's okay. And your whole numbers, what do I get? It's 0, so this is my final answer. Thumbs up if you had that. Excellent. Okay, I think we're ready to try some independent practice.